Using the SIN USA data in SAS, Module 7.2.1, see parenthesis here, Healthcare Analytics class. So in previous modules, we talked about the literature review and our goal in terms of our table that we're going to be using for this. For this, we're going to move on to looking at SAS Studio and program this exercise out. So let's get to SAS Studio. We're going to leave this course here. We're going to go into SAS Studio, sign in. Now there is, if you haven't seen, a sort of a system to this. So the program that we're going to be reaching into when we first get there is going to be Proto 7. So this is still up from some of the work we had before. We're going to get rid of My Little Pony, buy that, and then go into Proto 7. So just as before, we want to start customizing this program to make it our own. So we're going to save as something else. We're going to put this in My Courses. We're going to call this Last Week because it's the last week before your health affairs pieces are due. So I'm really looking forward to seeing how you generate those. And what questions you've asked and how you've approached them. So again, if we just run this the way it is raw, it won't work. Just to prove it, there's our errors. And go back to code. What we need to do again is just as before, go and find the sources that we're running. We're going to be running 15 again. We're going to look at properties. I'm sure you guys are becoming all pros at this now. We're going to then copy the piece that we need, Control C, close, paste in, paste in, and then down below, we're going to do a little bit of work of this here as well. So there's a lot more programming in this one. Talk about that in a second. So this is where we then put this piece here. So we're going to look again for where our files are all going, just down below here. You can kind of see them all lining up here. So what we are going to do is let's focus on, say, the week 5 one as an illustration. Look at properties, look where they're located. And we're just going to take that piece there, Control C, close. We're going to replace, oops, not too much of that. Now the trick with this one, this is going to be a little more complicated because if you'll notice, there's actually not just one of these, there are 3 of them. There's the first one, that's the overall table. Then we have one for diabetes. And then we have another one for CHF. So that's what makes this a little more complicated because you're really getting at 3 different output files. So let's talk a little bit about this program before we run it. We start off by bringing this thing called Betos codes. You might say, what are Betos codes? If you just Google Betos codes, you realize they stand for people's names, Berenson Eggers. Bob Berenson is a great actuary, works for CMS. Betos Mexican food. I should check that out. But actually, Betos codes. So you even have a Wikipedia reference. How cool is that? So it actually gives the reference for some of the codes in their descriptions. Here's just a brief preview to see what's going on. Now, the idea of this is actually pretty cool. The thought is that we're going to take all of the procedure code systems, HCPCS CPTs, and put them into a fairly limited subset of categories. So it's really taking tens of thousands, or well, not quite 10,000 really, a little less, of CPT4 codes and mapping them. So we're going to be, we actually did that, or we have basically a format that actually does that work for us. And we're actually then picking the Berenson Eggers codes that we're going to say are Office MD services, outpatient, hospital, and then hospital services. So if you literally map in, say, 01 to 14, you go back to the Behrens-Neggers reference, you realize 1 to 13 at least are those codes. Okay. All right, so back to Studio. Then we look here, and we then bring in our claims file. We actually do a little bit of reformatting for the data in terms of recoding a field, because we need to actually create something that's going to be able to count days for the readmissions piece. We then start counting off first the service use components of what's there. These categories were identified previously, so we have office visits, chiro, optometrist, home health, resident, and now not all these things we use, but we actually have them based on a combination of place of service codes, CMS specialty codes, and VETOS codes as well to create these counters. We then do something similar where we actually look at primary care visits, hemoglobin A1C in emergency rooms. We have different code sets for how we do that. So in the case of emergency rooms, all these CPT4 codes in their ranges. For primary care visits, we have to look at the place of service, basically in the physician's office or an outpatient setting. These are the CMS specialty codes for essentially group general practitioners, family practitioners, internal medicine, OB, and PED. So remember when we did some of that specialty analysis in the JAMA article when I showed you that earlier, that's how we actually map these. And then we're using these essentially to count all these different services. And so it's not really, this is a pretty tedious thing if you wanted to program it like a Familia 6562 and SQL. We're trying to, instead of doing a whole bunch of SQL queries, we're sort of in one pass of the data create a whole bunch of statistics, which is very efficient for large databases. And then we do a proc means to just test to make sure that that wasn't so crazy. And then we get into readmission rates. We actually identify dates in terms of SAS dates, which is the number of days from January 1st, 1960, and then add to that the length of stay dates. This gives us a first and last discharge date. We sort it, and then we use a variable that's something, a function in SAS that's awesome, lag. Basically, it remembers the previous observation's first date of service measure. And then we basically are saying if that is less than 1, then we're basically saying it's the same day procedure, we don't care. But if it turns to be different than that, we're actually going to put a starting reference in. And that starting reference will then be what we use for the readmission rate. We merge this back with this admission discharge date in together. And what we do then is create a reference date, which is the lag of the discharge date. We create a gap variable of the SAS admission date minus the reference date, and basically set in motion how we're going to count admissions, readmissions, and see. So, for example, now the gap, if it's 0 to 30, readmission is going to be added. If it's basically a count to it. If it's 0 to 90, then that's going to be counted. We count days of total days of hospital care by the person for the year. Say if the last person's ever output, so it's a summary of all those things coming together. We then go further for diabetes. We actually then identify whether they have the disease or not. We then count different pieces for them in terms of what their admissions might be on their claims. We have to first of all identify that they have diabetes too. So we did a little bit of this work before when we counted the diabetics in the week 3 module. So we put out the flags for that. And then with those flags, now we know who's a diabetic and who's a CHF patient and the other use and quality metrics. We merge all this together, and then we have all our summary statistics. And then we output it, run proc means, and then put it out as tables. So a lot of programming going on here just to create those metrics. And again, as far as you can take any one of these apart, you can break it and then fix it by bringing in the original prototype and see how it actually works. That's how a lot of folks learn. But just to give you an illustration of how to build one of these metrics, this is they're kind of art forms to create them, but everyone has a different approach. This is one approach, but it's one that will work to generate these metrics. And a lot of this went into making those tables that you saw from before. So we're running long on time. Let's just close by running this program, putting the whole thing through the running man. And I'm going to pause the clock here for a second until it's done. Okay, so we're back, and the program's now running, and ran, and then we see the results. So we basically get 3 separate sets of proc means this time. We get one for the total population, with basically the mean value for all of these different pieces. And remember, this is the count of the people that might be in play here. So, say for the foot amputation procedure in our population, that affects 64,000 people in ESI, even though it's a very small number. You can see there's a fair number of physician office visits, not many home health visits. Hemoglobin A1C is actually pretty, for the test itself for the total population, it's pretty small. Now, when we get to ESI population for, this is the first one's for diabetes, much smaller population, hemoglobin A1C test is much bigger, 1.73 tests. Remember, this is reporting not the proportion, but the tests. We're just looking at raw statistics right now. And then you can actually program, if you're very good, get more proficient with SAS, you could just program this out to actually figure out just a dummy variable for hemoglobin A1C2, but we're not doing that for this analysis. And then this is the CHF means that comes after a smaller population. Hemoglobin A1C down a little less. Sometimes there's overlap between the two populations. And then you can see the readmission rate that goes along with these as well. So readmissions for CHF, 30 days. It's not so much of a proportion there, but this is the count, which for the ESI population works into 110,000 readmissions. Medicare fee-for-service is about 321,000 for this particular disease. So this gives us a flavor for this week's analysis. The next thing we have to do is to then customize this program, and let's save it quick before we forget. We're going to customize this program for the state analysis. This concludes this module about using your SIN data in SAS to create the Week 7 analytics.